Hello, this is Ellie from the Math Center, and today we're going to be talking about sequences. I have two sequences written here. The first one is e to the 5n over 3 minus e to the 2n, and this sequence goes from n equals 1 to infinity. And the second sequence that I have is n squared minus 7n plus 3 over 1 plus 10n minus 4n squared, and this sequence goes from n equals 3 to infinity. So a sequence is a set of numbers, a set of ordered numbers. So if you wanted to write the first few terms of a sequence, this would be such as a1, in this case would be e, and we start with the n equals 1 down here. So e to the 5 times 1 over 3 minus e to the 2 times 1. So we'd get e to the 5th over 3 minus e squared. A2 would be e to the 5 times 2 over 3 minus e to the 2 times 2. So this is e to the 10 over 3 minus e to the 4. And this goes on and on up until your last number, but here we're going up until infinity. So to determine if a sequence converges or diverges, we look at the limit as n goes to infinity. So here, to determine if it converges or diverges, we write the limit as n approaches infinity of e to the 5n over 3 minus e to the 2n. As we input, if we input infinity into this case, we will actually get infinity over negative infinity, implying that we can use L'Hopital's rule. If you need a refresher on L'Hopital's rule, we have another video on our channel. So after applying L'Hopital's rule, we get the limit as n approaches infinity of 5e to the 5n over negative 2e to the 2n. This is equal to the limit as n approaches infinity of 5 over negative 2e to the 3n, which approaches infinity. Since it approaches infinity, we say that this sequence diverges. This other sequence that we have over here is two polynomials, or is a polynomial over another polynomial. So similarly, if you wanted to write out the first few terms of the sequence, such as a1, this we would actually start where the sequence says to start at n equals 3, and we'd have 3 squared minus 7 times 3 plus 3 over 1 plus 10 times 3 minus 4 times 3 squared. This is equal to negative 9 over negative 5, or 9/5. Likewise, we can do this with a2, which is 4 squared minus 7 times 4 plus 3 over 1 plus 10 times 4 minus 4 times 4 squared. The numerator here is equal to negative 9, the denominator to negative 23, or 9/23. This also goes on, because until our top limit, but here our top limit, our final number is infinity. So if we want to check whether this sequence converges or diverges, we take the limit as n approaches infinity of n squared minus 7n plus 3 over 1 plus 10n minus 4n squared. This is very similar to taking to finding a horizontal asymptote of a function, and we can divide every single term here by n squared. this is a method of finding the this limit. So this is the same as the limit as n approaches infinity of n squared over n squared minus 7n over n squared plus 3 over n squared over 1 over n squared plus 10n over n squared minus 4n squared over n squared. Now, as n goes to infinity, every term with an n squared in the numerator that does not have an n squared in the every term with an n squared in the denominator that does not have an n squared in the numerator will go to 0. So this term here goes to 0. This term here goes to 0. And these two terms also go to 0. Oh. So, yeah, so what we end up with is the limit as n approaches infinity of 1 minus 7 over n plus 3 over n squared over 1 over n squared plus 10 over n minus 4. Since all of these terms go to 0, this equals negative 1/4. Since it equals a number, we can say that this sequence converges.